So you can see this problem, and I section is simply supported over a span of 12 meter, right? So if the maximum permissible bending stress is 80 Newton per mm square, what concentrated load can be carried at a distance of 4 meter from one support? So there are given I section, simply supported beam, span given L 12 meter. Maximum, if the maximum permissible bending stress given, sigma maximum is 80 Newton per mm square, what concentrated load W can be carried at a distance of 4 meter from any one support? That is their question. So bending stress sigma maximum given as 80 Newton per mm square, they are asking W. W is nothing but concentrated load carried at a distance of 4 meter from the support B, right, in Newton. Right. So the I section dimension given 100 mm flange with 11.5 mm thickness of the flange, web thickness 7.5 mm, and okay, so values given. So here, so this is the beam support. The length is 12 meter. Support A, support B. So from the support B, assume that at a distance of 4 meter, the W concentrated load W is acting at a distance of 4 meter, right? So at A point, the reaction will be RA, and at B point, the reaction will be RB. So first of all, we need to find out the RA and RB. So to calculate the support reaction RA and RB, you need to apply the equation. There are two equations. One is sum of the vertical force is equal to sum of the downward force. RA plus RB is equal to W. That is one equation. Another equation is sum of the moment at A equal to 0. So here, if you see the value RB is minus RB into 12. This we're taking section at AA. So therefore, this is towards the section. It is towards like anti-clockwise direction. Therefore, here minus. So here they are considered plus. You don't need to worry about that. You can follow whatever we followed the procedure, like minus RB into 12. Then towards the section A, this W is towards clockwise, so plus W into the distance is 8 meter. So plus W into 8 equal to 0. Therefore, this will go that side. The plus RB into 12, which is equal to 8W. And this yeah, RB equal to 8W divided by 12. So 2 by 3 W. So RB equal to 2 by 3 W. So in this equation 1, you can substitute RB equal to 2 by 3, you will get RA, that is nothing but W by 3. You know RA plus RB equal to W. So RA plus RB is 2 by 3 W equal to W. So RA value is W by 3. Right? Then bending moment M. So bending moment at A. So simply supported beam at support A, you know the bending moment value is 0. Similar at support B, the bending moment value is 0. Moment at A equal to 0, moment at B equal to 0. And bending moment at C. Moment at C means RA into at C point is distance from the A is 8 meter, right? So here you can see this diagram here at point is C. Suppose RA into this distance is 8 meter. So here you can see MC equal to RA into 8. So RA value, you know, W by 3 into 8. So 8 by 3 W is the bending moment at C. Right. So the bending moment at C is the maximum. So 8 by 3 into W Newton meter. Therefore, Newton mm we convert. Therefore, 1000 W Newton mm. So this is the maximum bending moment value, 8000 by 3 W Newton mm. Now you can find the moment of inertia of the I section about the neutral axis. So you know how to calculate the moment of inertia. So B equal to 12 minus the remaining hatched portion. If you deduct, you will get the moment of inertia value. And you know the bending equation M by I equal to sigma by Y. So M by I equal to sigma maximum by Y maximum. Y maximum is nothing but total depth D225 divided by 2 D by 2. So if you substitute Y maximum, you know, and moment value 8000 by 3 into W, sigma maximum value, you know, moment of inertia. So sigma maximum given in the problem. So if you substitute the unknown value W, the concentrated load W, you will get. Okay. So this is how you have to calculate the values. Okay. So thank you for listening.